starting with the Nsx Logical Switch. So in our diagram here, and we're going to use a lot of diagrams in this lesson. In our diagram here, we see a physical network. We've got two ESXi hosts on the left, two ESXi hosts on the right, and in the middle, we've got physical switches and a router interconnecting these ESXi hosts. And what I would like to do is create virtual machines on these ESXi hosts that reside on the same layer 2 network. However, given my physical topology, this is not possible. I've got a router in the middle. A layer 2 network cannot span a layer 3 physical router. So, with a traditional vSphere distributed switch or vSphere standard switch, I cannot accomplish this network topology as shown. But if I deploy an Nsx Logical Switch, here we see an Nsx Logical Switch. It's identified by something called a VNI. That's just a VXLAN network identifier. It simply identifies this particular logical switch. And I create this logical switch. It actually has the ability to span a physical layer 3 network. It creates something on these physical ESXi hosts called a VTEP, or VXLAN tunnel endpoint. And you don't really need to understand exactly what the VTEP is or exactly what a VNI is. The exam isn't going to cover those sorts of topics. But what you do need to know is that what happens here is that there are these tunnels that get created over the physical network, directly interconnecting all of these hosts. So if you're a visual person like I am, think of it this way. All of these VTEPs have a connection to all of these other VTEPs. They're aware of the other VTEPs in the network, and they can communicate with the other VTEPs in the network. So if the VTEP on host 1 has some layer 2 traffic that needs to get to host 4, here on the far right, it can make that happen. It can take that traffic that's coming over layer 2, it can pump it over the appropriate little tunnel here that it has established, and send it over to the appropriate VTEP. Even though it's a layer 3 physical network, it doesn't matter. All these VTEPs establish these tunnels between each other, and therefore are able to pass layer 2 traffic regardless of the physical network topology. So now, what does this give us from a functional perspective? What are the capabilities that this creates for us? And the big thing is, now I can create layer 2 networks completely in software without changing anything on my physical network. So if I decide I want to create a new network, I can simply create a new logical switch, and I don't have to configure anything at all in my physical network. So I am decoupling these network components from the physical network. And decoupling is always the goal of virtualization. So this is virtualization for my networks. Now I can create network components independent of the underlying physical hardware. And that gives me a whole ton of flexibility. It also gives me the ability to automate the creation of network components. Next, we're going to take a look at the distributed logical router. But before we do that, let's take a moment to think about how we have traditionally routed traffic in a vSphere environment. So here we have two virtual machines. These VMs are running on the exact same ESXi host. They have different IP addresses on different networks. And so VM1 is on the 192.168.1 network. VM2 is on the 10.1.1 network. They're on different networks. And that'll work just fine. But in order for those virtual machines to communicate with each other, their traffic needs to be routed. A router is what interconnects these different networks. So for VM1 to communicate with VM2, it is going to generate a packet. It is going to send that packet to its default gateway, which is this physical router. And so the packet needs to flow through the physical adapter of the host, through a physical switch, hit a physical router, get routed back to the same physical switch, back to the same ESXi host, and eventually reach its destination. And these two VMs are running on the exact same host. So you can see how that traffic pattern isn't really optimal. Ideally, that traffic would never have to leave the ESXi host. That's where the distributed logical router comes in. The DLR does is it's a little router kernel module that's installed right into ESXi. It sits right on your ESXi host as a hypervisor kernel module. And if you ever hear that term, it just simply means this is baked right into ESXi. And so now when VM1 needs to communicate with VM2 and that traffic needs to hit a router, there's a router local to that ESXi host. And so the traffic never needs to traverse the physical network in order to be routed. And that's the beauty of a DLR. So number one, it's going to give you a more optimal traffic flow because traffic isn't going to unnecessarily hit the physical network. That's what we call hairpinning. And I'm not sure this will come up on the exam, but when we talk about packets being unnecessarily sent to the physical network and hitting devices that they don't really need to hit, that's hairpinning. The DLR eliminates that hairpinning by performing the routing right within the hypervisor. So that's one of the big features of the distributed logical router. But the other big benefit is, again, it is a software-defined component that can be created or destroyed on demand without any changes to the physical network. Next, we have the distributed firewall. And this is one of the most popular reasons for implementing NSX. This gives us the ability to do micro-segmentation. So in this diagram, I've got VM1 and VM2, and they are on the exact same ESXi host, and take a look at their IP addresses. They're on the same network. They're connected to the same virtual switch. So in the past, how would I possibly implement a firewall policy to control traffic between these two VMs? I would have to have something inside of the operating system. Maybe I'd use the Windows firewall or something like that, or some third-party solution. The only other way that I could implement a firewall policy on two virtual machines like this is I could take them, put them on different networks, and force their traffic to flow out to the physical network, hit a physical firewall, implement my security policies there. But these VMs would have to be on different networks. I would put them on different VLANs. I would put them on different IP networks to make that happen. So what we ended up with is a whole bunch of subnets, a whole bunch of VLANs, a whole bunch of complexity in our network, just in order to force certain traffic through firewalls. And I still couldn't do it with every single virtual machine. It's infeasible. I can't apply security policies to every VM unless I'm using some guest operating system based tool like Windows Firewall. The distributed firewall overcomes this challenge. I want you to think of the distributed firewall as essentially, I've got a little firewall here. I've got another little firewall instance here. This is run as a service in our ESXi host called the VSFWD. And what that means is I can have a specific policy for this virtual machine. Maybe this virtual machine is a database virtual machine. So I can have a set of rules for incoming and outgoing traffic for this VM. I can have a set of rules for, maybe this is my application server, for incoming and outgoing traffic for this virtual machine. And even though they're on the same logical switch, that firewall policy is applied before their traffic even hits the logical switch. Before the traffic, so the next step would be to hit their logical switch. So those firewall rule sets are applied before the traffic is even switched. It's like every single virtual machine has a firewall bolted onto its network interface. And this is what allows me to perform what we call micro-segmentation, where I can apply traffic rules anywhere in my network. And this is a huge win for things like compliance. This gives me a whole host of capabilities for internal security. And it also significantly cuts down on complexity because I don't have to have a whole bunch of VLANs and subnets in order to execute my security posture. Nsx Manager is our management plane component, and we're going to talk about it in just a moment. but I'd just like to point out here, Nsx Manager is the tool that is used to configure all of these firewall rules. Nsx Manager talks to these hosts directly to get those rules configured. Next on our list, we have our Nsx Edge, and I know this is a relatively complicated looking network diagram here, but I do want to walk you through it because we're going to do a review of everything that we've covered so far in this lesson, kind of put the whole picture together. So here on the left, I've got a virtual machine. It's called VM1. And this is my virtual machine that wants to get some sort of traffic out to the network. So virtual machine 1 is connected to a logical switch. And here you can see logical switch VNI 5002. It's present on both of these hosts. We've got our little VTEPs creating these tunnels through the network. So it doesn't matter that I have a physical layer 3 network under the surface. Logical switches can overlay and can extend a layer 2 network across a layer 3 physical network. So anyways, VM1 wants to get some traffic out to the internet. So it sends that traffic to its default gateway. And its default gateway is its router. And that's right inside the ESXi host. It's our distributed logical router. And the distributed logical router looks at the destination of that traffic and determines, hey, this traffic is actually bound for the internet. So what the distributed logical router does is it does what any router does. It looks at its routing table and it says, how do I get this traffic towards the internet? And it determines that the next hop for that traffic is something called an Nsx Edge. It's another router. This is what we call our north-south router. The edge is connecting my NSX domain to an external physical network. That's how internet traffic gets in and out of my NSX domain, is the Nsx Edge. And the Nsx Edge is also kind of like the Swiss Army knife of the NSX environment. It does VPN, it does load balancing, it does network address translation, it provides a firewall, it's a router, it does a little bit of everything. So that's the Nsx Edge. The Nsx Edge is a virtual appliance. It's a virtual machine. It's not a kernel module. It's its own independent virtual machine that runs on one of these ESXi hosts. So let's follow this traffic one more time as it goes through the network. VM1 generates some kind of ping destined for an external physical network. It hits the logical switch. The logical switch sends it to the distributed logical router. That's my default gateway. That's my router. And so the packet then is transmitted over my physical underlay network to the Nsx Edge. The Nsx Edge looks at its routing table, determines that this traffic is bound for the internet, and away it goes. So how do I manage all of this stuff? There's a lot of components involved here. The list that we've looked at is actually a partial list. There's other things that can be set up. So how do I manage all of this? Well, I'm going to use Nsx Manager. This is our management plane component, and it integrates with vCenter. Every Nsx Manager instance has a one-to-one relationship with a vCenter server. And so I can use the vSphere web client or the HTML5 vSphere client to manage all of this. The Nsx Manager is my REST API server, so any API calls that are made to NSX are made against the Nsx Manager. And it's used to create many of the components that we use with NSX, like our Nsx Edges. It's used to deploy all of our NSX kernel modules, like the distributed logical router. And it's also used to create the Nsx controller cluster. And this is our control plane component. So this is used to do things like manage our logical switches, manage the configuration of our routers. And anytime we're talking about the control plane, it doesn't pass any actual virtual machine traffic. So with NSX, we've got three planes. We've got the management plane, the control plane, and the data plane. The management plane is Nsx Manager, and it is used exclusively to configure and manage the environment. The control plane is kind of like halfway between the management plane and the data plane. The control plane is not going to impact traffic if it fails. Neither does the management plane. If either of those planes fail, if Nsx Manager fails, nothing goes down. I just lose my ability to manage. If the Nsx controller cluster goes down, nothing breaks. All my traffic keeps on flowing. But with a control plane failure, it will eventually impact traffic. It may slow things down. I don't have any actual virtual machine traffic flowing through the control plane, but it does perform some functions that are critical to the ongoing health of my network. Whereas the data plane, this is where the VM traffic actually flows. If there's a failure on the data plane, that's going to impact my virtual machine traffic. So the Nsx controller is going to handle some functions internal to my logical switches, internal to my distributed logical routers. It is very important that we keep these up and running at all times. Therefore, they are deployed in clusters of 3 virtual appliances running on 3 different ESXi hosts. Now finally, I just want to take a look at a little bit of documentation here and mention a few things that you should bear in mind if you are preparing to take the VMware Certified Associate exam. So what we're looking at here is the VMware documentation for NSX. And if you just go to Google and type in NSX docs, DOCS, you'll find this. This is the NSX for vSphere documentation, and I've specifically gone to the NSX Administration Guide. And under the NSX Administration Guide, there's something that I want to encourage you to read prior to taking the exam. The NSX Data Center for vSphere Components. I want you to go and read on what is the data plane, what is the control plane, what is the management plane. Those are 3 things I think are worth your time to read, because what you'll find is a lot of the exam questions are based very closely on this documentation. And these are 3 areas of the documentation that are definitely going to be covered on the exam. It would also be worthwhile to give a quick read to the Nsx Edge and Nsx Services areas as well. But I would say those are less critical